Hello and welcome to GIS 311 day/week 10. This is likely the last GIS 311 video lecture of your quarter. I'm hoping you watch this lecture prior to class so that we can have a detailed discussion and get all of your questions answered during the in-class portion and demos as you wrap up your final two mini labs. This image is of one of your labs. This is earthquakes around the globe on a specific date. You'll be creating a very similar web map of earthquakes that occurred 24 hours prior to when you download your data. And we'll talk about that more in just a moment. Please review Canvas for your due dates. We're wrapping up the quarter very soon, and there are plenty of due dates coming up, especially if you've missed some labs or if you're getting behind on the labs. Remember, lab help is always available if necessary. Hugh is in the classroom many days during the week. His schedule is posted on the doors in the lab and the lounge. And as you may recall, I come into the classroom at least by 3:30 almost every Wednesday to give for my office hours and to give assistance where needed. We will have a few maps of the day or interesting maps if there are submissions. And while this isn't the 2024 version of the WGISA conference, you may want to look into the WGISA 2023 conference and attend on the 11th, 12th, and 13th. Remember, you may do so for free. And then there's this little canine puppy. This dude or dudette, I'm not sure which it is. This canine is resembling the Quiz 9 or Lab 9. I just thought it was a fun image to put on there, in addition to the two mini labs in the previous slide, excuse me. So this is our final day. General tentative plan is the same. There will be some lecture and demos, mostly demos because this is your lecture. We'll talk about sharing data, some things about the legend, and then it'll be an open lab for you to work on your Lab 8 and Lab 9. And please realize that those are very short. They're 9 pages for Lab 8 and 8 pages for Lab 9. So even the two of them combined is smaller than or shorter than any other lab you've done this quarter. And they're two of the easiest labs in the whole course. If you'd have done them first in this class, of course, they would be impossible because they're all new material and you haven't been through all of the other labs previously. But now that you've been through all the labs, Lab 8 and 9 will be a cinch for you, and everybody should be able to finish them in class on our final day. I posted up another image of the earthquake map. This is my work from, I believe it was the 25th to the 26th, 24-hour period of earthquakes around the globe. And I've symbolized them in purple and the dark background. So again, Lab 8 is 9 pages. You're going to create one web map. There are bonus options. You can add other relevant data to your web map for some bonus points, or you can go completely in a different direction, and after you've done your web map, you can create a web application. The only criteria for that is you cannot create a web application using Web App Builder. Web App Builder is going to be discontinued, and there's no sense of you using it now. It'll be quite virtually not available in less than a year. I believe it's March 2025. So there is no point in using it. You should use something like Experience Builder or some other method to build an app if you'd like. Remember, that's a bonus for extra credit. Some key points. You'll be using ArcGIS Online in Lab 8. It's often abbreviated as AGOL or AGO. I'm not sure which Esri prefers, so I use both. ArcGIS Online, or AGOL, is a SaaS model, software as a service. And that means that it's different than ArcPro. It's a service that you can access from any web browser, including a Macintosh computer or a Mac computer or Apple computer, whatever they're called these days. Your login is the same. So when you log into AGO, you'll log in using your UW credentials. It's imperative that you log into the University of Washington Tacoma organization of ArcGIS Online. And that's why I put up the homepage and also the organizational view of our organization. You must be logged into these. Your name will show up in the top right, and your credential will show below it. Mine happens to be my name with no space. ArcGIS Online integrates with ArcPro, and you've already utilized some of that technology. You've shared data from Labs 5 and 7 to ArcGIS Online, and you'll be able to see some of the amazing ways that ArcPro and ArcGIS Online can collaborate together to go back and forth between Pro, the desktop software, and ArcGIS Online, the SaaS, software as a service. UW-T, as I already mentioned, has its own ArcGIS Online organization. This is strictly for UW-T use. It's administered here at UW Tacoma for the entire campus. Other classes use it as well, but primarily it's the School of Urban Studies and our GIS classes. Some other classes, such as urban design, students use it, and in environmental science, some of the instructors or faculty, professors are having their students create story maps using ArcGIS Online. So it's a great thing to have. It's a great resource. And some people go off and have a full-time job using only ArcGIS Online. They don't even use ArcMap or ArcPro anymore. So again, it's a software as a service model. It integrates with ArcPro. We have our own organization. In the organization, we also have groups, and you're all part of at least one group. You're in the spring, or I should state it this way, you're in the quarter and year all together with everybody in your same class or your same section of GIS 311. If or when you get into the GIS certificate, all of you will be in a GIS certificate group labeled by the quarter and the years. And that would be 2 years because it goes from an autumn to a winter quarter. So it spans 2 years, even though it's only 2 quarters long, the latter part of the GIS certificate. So you'll be sharing some of your work to a group in this lab, in Lab 8. And again, you'll create just one web map with an option to add data or create a web application for extra credit. The process is very simple, and I've laid it out in some images. You'll go to the USGS website. You'll find where you can download spreadsheets, and you're going to download the past day, all earthquakes. You don't even need to open this up in Excel, but I did to show you that it's a simple Excel spreadsheet. It's a CSV, but it opens up like a spreadsheet. And then there are 6 specific fields that you're going to use once you get into ArcGIS Online. And I've added arrows above them. as you can see. Time, latitude, longitude, depth. That's the depth of the earthquake. The magnitude and place. You may end up using, let's see, the location if you'd like, but you definitely don't have to. I may have forgotten one of those when I did my little demo, so mine might look a little bit different when I show you in class. But the directions work and you should be good to go. So again, the first part is shown on this screen. You download the spreadsheet or the CSV, and then you open up ArcGIS Online. Oh, and by the way, this data will be saved in your raw data of your Lab 8 directory. Here's another descriptive slide just showing you how this works. You'll click on the grid up near your name at the very top of the page, and then you'll open up Map Viewer. From there, you'll change the name and you'll add data. You change the name, by the way, by pressing Save and Open. Just follow those directions carefully. It's only 9 pages of directions with several screenshots, so it's super short. Once you save the name, and I was right, it was the 25th to the 26th of 2024. Then you add data from a file. So you're adding a layer from a file, and then you're going to create a hosted feature layer and add it to the map. Very simple process. From there, you'll symbolize the data. I ask you to use UW purple by using the edit button on the fill for the symbol style, and it'll change to purple. And then you'll have your map. You save it a few more times, add a couple other details to it that are provided in the directions, and then you'll share it. So when you share, there's usually 3 different icons, perhaps 4. There'll be just you, that's a little person. There's U plus, and then probably something that says G that represents a group. Then there'll be the organization. That may look like a bunch of buildings. And then up above organization, it's everybody. So this is public. I have shared mine to be public, which is why there's a globe. You do not have to share your work as public, but you do have to share it with the organization or the group, whatever I specify in the lab. The reason behind this is there's pedagogical evidence that shows that sharing your work with others, your peers, is a pedagogical style that works. Comparing work and comparing yourself to others or others reviewing your work is helpful for you to improve. So thus, we're not sharing this out to the entire world. We're not going out public, but we're sharing it within the organization so we can facilitate additional learning. And again, I just shared it with everyone because I figured, what the heck, I'll get it, show it out there, whoever wants to see it. So you should be able to see my map, by the way. And then towards the very end, you'll need a link to submit to Canvas. So you'll go into the details. Again, this is all described in the directions. You'll go into the details and you'll click this little link. The arrow is pointing at the share button, and that'll get you a very short URL. You submit the URL and you're good to go. So there's the whole process of Lab 8. 9 pages, very, very easy, and it's a good overview of ArcGIS Online. Then you're going to switch gears to Lab 9 or Quiz 9. And Quiz 9 or Lab 9 is all about feature data sets within the geodatabase. Up until now, you've utilized shapefiles, feature classes within a geodatabase, and of course the geodatabase. The geodatabase holds feature classes, as you've done. They also hold things called feature data sets, which you're going to start utilizing in this lab. They also hold rasters, as you've done in previous labs. And all GIS labs moving forward at UW-Tacoma, particularly in the School of Urban Studies, you'll probably be using at least one project geodatabase, the default, and a raw geodatabase, and perhaps 2 feature data sets. For sure, you'll be using at least one feature data set. As a definition, according to Esri, at its most basic level, an ArcGIS geodatabase is a collection of geographic data sets of various types held in a common file system folder or a multi-user relational database management system such as IDM DB2, Microsoft SQL Server, Oracle, Postgres, SQL, or SAP HANA, which I have never used myself. Geodatabases come in many sizes, having any varying number of users. You've primarily been the sole user of your geodatabase, but they can be used by others. And they can be built on files up to a large root group, a department, or enterprise geodatabases accessed by many users. But even for our purposes, a geodatabase is more than a collection of data set. The term geodatabase also has the following meanings in ArcGIS, according to Esri. The geodatabase is the native data structure for ArcGIS and the primary data format used for editing and data management. While ArcGIS works with geographic information in numerous geographic information system formats, it is designed to work with and leverage the capabilities of the geodatabase. It is the physical store of the geographic information, primarily using a database management system, or file system is another term for it. You can access and work with this physical instance of your collection of data sets either through ArcGIS or a database management system similar to SQL. Now, we don't use SQL or SQL. We use it in ArcGIS. Geodatabases have a comprehensive information model for representing and managing geographic information. This information model is implemented in a series of tables holding feature classes and attributes. In addition, advanced GIS data objects and real-world behavior, rules for managing spatial integrity, and tools for working with spatial relationships of the core features and attributes. And you'll learn more about that in later classes. We're going to try to keep this to the nuts and bolts of a geodatabase and a feature data set. In this image on the screen, there's several images, but in the top left image, there's the normal geodatabase. You've utilized those, and if I asked you on a quiz, pick out the default geodatabase, you would definitely pick the one with the house on it, because you know that's the default geodatabase. What is new to you, likely, is this feature data set. And this feature data set is something that you'll be creating in Lab 9. Feature data sets hold similar data groups together. So that's why some of your projects might have multiple feature data sets within a singular geodatabase. Then please be aware that I call a feature data set an FDS and a geodatabase GDB, as you're become accustomed to, I'm sure. And this lab is just 8 pages long with all the screenshots. It's short and it's relatively easy. Our focus is on the new item, the feature dataset that is housed within your default geodatabase. I put up 2 images of a geodatabase, one in Windows right here, and then a solo version right here that's in Arc. So we cannot manage our geodatabase in Windows. Windows isn't a database management system. It's not SQL. It could be, but it's not. So we can't manage it. We can only look at it. And in Windows, a geodatabase pretty much looks like a folder, but it's much more than a folder. It's a bunch of tables actually that work together to help you organize your data and do GIS processes. In Arc, you can work with the geodatabase. And here I haven't expanded it. There's a right arrow that would be a down facing arrow, like up here, if I were to expand it. And then here's an image of a geodatabase from Esri. I put the link right here. There's multiple tables, there's feature classes, and then there's raster data sets. That's what goes in your geodatabase. From now on, you will never have a feature class within your geodatabase. Your feature classes will be in a feature data set within the geodatabase. And I'm going to talk about how that looks in the next slide. But you'll notice that these feature classes are indented underneath the feature data set. And the feature data set is indented underneath the geodatabase. So I can tell that this feature data set is within this geodatabase and these feature classes are within this feature data set. So this slide might look confusing, but there's a method to my madness. The image on the left is your Lab 9, your final directory, so to speak, of Lab 9. You're going to have two different geodatabases. You're going to create this raw geodatabase that's not the default geodatabase. Notice the default is up here. And you're going to have two feature data sets. There is nothing in this feature data set that was for practice, and you'll create one for practice as well. In the upper part of the image, you can see that there are feature classes within the feature data set. That's what you're going to complete. You're going to add these feature classes to the feature data set. In addition, you're going to store two rasters within the geodatabase, along with one table in the geodatabase. So how do you know which of these things is in or within the other things? So I've decided to show you using some straight lines. So if I draw a line through the feature classes, I can tell that they're the only things indented that far. So I go out to the next furthest thing above them, and then I can see that, oh, okay, they're in the feature data set. And you'll get used to recognizing that these are indented underneath the feature data set. So when you're saving these, you have to make sure that you're sending it to the feature data set so that they live in there. We do not want them lined up with the feature data set. If they were in this line, that would mean that they're in line with the table and the two rasters along with the feature data set, meaning that all of them would be in the geodatabase. So this is a perfectly good image. They are in the right location. And I can tell that by the lines that I've drawn, and I'm just so used to it. The lines are to help you. You can also realize that the geodatabases are on their own line because they're the kind of the lead directory. They're the top two things within your storage area of your project. And then this last one, instead of putting the line right through the icons, I put it up to the icons. So you can see that these four items are still indented from the previous line, and that this feature data set and the table and the rasters are indented from the geodatabase. And of course on the bottom, the feature data set is indented from the geodatabases. So this feature data set is in a geodatabase. I will tell you though, there actually is no way to screw up the feature data set. The feature data set cannot exist outside of a geodatabase. So you'll never see a feature data set lined up with a geodatabase, because you also can't have a geodatabase within a geodatabase. But the hardest part is realizing that you have rasters and a table and a feature data set all within a geodatabase, and then your feature classes within a feature data set from now on in your UW Tacoma GIS courses. At the very bottom of the slide, what's important for using your feature data set properly is to set your environments. We've been setting these things since the beginning, but now there's a little bit of a change. You'll be setting your current workspace as the feature data set instead of the geodatabase. And this helps you when you go to do any function or any tool, it'll try to put it into the feature data set. Now, if you're working on a raster will not go in a feature data set. It has to go to the geodatabase. So you'll likely see that despite this saying feature data set, if you ever perform a raster function or a tool for rasters, it will go to your default geodatabase as long as you've set this up so that these lead directly to your default geodatabase. And performing these tasks is a lot easier, a lot more efficient in helping you learn about this than just listening or watching on the screen. So that's why you're going to do a little bit of this work in Lab 9. Last but not least, I've been mentioning this for several weeks, but now it's very important that you set your output coordinate system. And in this case, you'll set your output coordinate system to what we want it to be, which is state plane Harn South, or that's how I call it. I abbreviate it that way. That will help you get your feature classes into the feature data set with the proper coordinate system. A feature data set can only have layers with the same coordinate system. In fact, your feature data set even has its own coordinate system, which will definitely match all of the feature classes that are stored within it. So you'll see how this works while practicing, and I'll likely have a demo in class, a live demo. Be sure to set your environments before you do any analysis and start working with your data. Set your output workspace, your current and your scratch, and then your output coordinate system. And this concludes the video lecture for week 10 and labs 8 and 9 preparation. Please feel free to email me if you have any questions. I've been answering emails all weekend. I'm happy to do so, even on today's holiday week. It happens to be a holiday today, the day that I'm recording this. I have no problem replying to students and helping you out. I look forward to seeing you in class and having you work on labs 8 and 9. Remember, they're short, they're easy. You should be out of there in a couple hours if you do the work there. Or they're actually all available right now. So if you're done with your work for the previous week or days, then feel free to get a jump start on these final 2 labs. And as I called them at the beginning, mini labs. Thank you very much. Have a great day, and I'll see you in class.